So in this video, we are going to see the second part of the assignment, that is create the representation of document by calculating term frequency and inverse document frequency. So for that, we need to understand some concept first. That is, first is what term frequency. So term frequency is what? It is the measurement of occurrence of word in a document D divided by total number of words in this document D. Suppose I have two statements. One is what? Jupiter is the largest planet, and second word is what? Mars is the fourth planet from the sun. Now, if I'm going to calculate what? My frequency of PF. So total number of words equal to 5. 1, 2, 3, 4, 5. Now, if I want to find out the frequency of Jupiter, so my frequency of Jupiter will be 1 divided by 5. Okay, 1 divided by 5. And if I want to find out what Jupiter frequency in the document 2, so it will be 0 because it is not present Jupiter in the document this particular. So this is the how we are going to calculate term frequency. Now IDF, total number of documents in the corpus. Here we have considered two documents, one document, two documents, and divide by number of documents that containing word W. How many documents the word particular W is present. Suppose I am going to consider the Jupiter. So Jupiter, out of two, only one document Jupiter is present. So I'm going to do logarithm of 2 divided by 1, that is 0.69. Now is present in both the documents. So 2 divided by 2 is 0. The is also present in both the documents. So the is 2 divided by 2 is 0. Likewise, we are going to find out IDF for every. Now, TFIDF is nothing but the multiplication of term frequency and inverse document frequency. Now we have the term frequency 1.5, that will be multiplied with the IDF of this particular frequency. So this will give us what? 0. Okay. Now what we have, next one is what? We have IDF and TF into IDF, that we are going to do. So this 1 divided by 5 and 0.69 will give you 0.138. 0 and 0.69 will give you 0. So for every particular document and every particular word, we are going to find out what? TFIDF. That is nothing but the multiplication of TF and IDF. Now, why we are going to consider the log? Because here we are going to consider the log, because here when TF values is lies between 0 and 1, so not using ln. If we are not using ln, IDF of some word will be dominating the TF-IDF term, because in TF-IDF we have both things, TF also and IDF, and we don't want that your IDF will dominate the word TF. So for that purpose, we are going to take the logarithm for the normalization purpose, and then we are going to do what? This particular thing. So here one more concept we are going to use, that is bag of words. So bag of speed means what? The text we are going to convert, that is what? Into vector of numbers we have to convert. So in natural language processing, when we are going to extract the features from the text, first it will convert it into the bag of words. So we need the bag of word for this procedure. So now we are going to cover how we can perform the document frequency. So we are going to first continue with this particular document only. So now we need what? Two libraries. One is pandas, because we need data frame to store our variable, and from feature extraction we need TF-IDF vectorization. Okay. So now first step is what? First step, we need our two statements. So suppose we have our two statements. Our two statements are Jupiter is the largest planet and Mars is the fourth planet from the world. Now very first step is what? We have to create the bag of words. We have to split it and we have to convert what? Bag of words. So bag of words for A document and bag of words for the B document. So these are my user defined variables, bag of words A, bag of words B, and I'm going to split it. Now if once I have the bag of words this, so now I need what? Unique words. I need the unique word, no repetition of words between A and B. So my unique words will be unique words from both the, we can say both the documents will be, it will be set of what? So set of, I have the bag of words. So I have the bag of words for A, and then I have the bag of words for B. So I'm going to do the union of it. So union of bag of words for B. Same, I have bag of words for what? B. So I'm going to do the union of it. And by union, I have the union of words, and bag of words is not defined. Bag of words. It is like bag of words, not bag of words. I need to define of that. So here, if we are going to print this particular unique word, so if I'm going to print it, it will give me unique words. See how many unique words we have: Jupiter, Mars, planet, sun, foot, from, is, largest planet, and the. Now I need is what? And now I need to declare the, in next step, I want to create the dictionary of my words. Dictionary will create what? Dictionary will the words with that occurrence of each document. हर एक document में every particular word का जो occurrence है, that I need to present in what? My dictionary. So if I will say that I want one variable, that is number of I need number of words, and number of words that I need is A. So number of words A equal to, I need dictionary. So DICT dot from which I need. So it is like from keys, and what I need to pass is I need to pass unique words. So I will write down unique words. Unique words, comma 0. So my unique words will be, number of words will be counted. Now every particular word, for every particular word in the bag of word A and in bag of word B. So if we can say for word in bag of, if we can say in bag of words A, now from bag of words A, I need to count what? Number of words, how many times that particular words will be present. So I need to write down number of words A. So number of words A equal to, every time when the word will present, it will increment the counter by 1. So I will write down, it will come increment the counter by 1. So now next is what? I want to again number of words from B. Again, I need is what? Number of words from B. And again, I want to do the same thing. So first we will observe this, and then we will do for the B. Same we want to do for what? Our B part. So we'll write B, and number of words A, sorry, number of words A, it should be of word. What we are passing? We are passing this variable word. So we need to write over here, that is word. Done. So now this will be done, I think so. And this is extra. So number of words equal to plus minus 1. Okay, this is extra. Done. So now if I'm going to observe, now this same I want to do for what? B. So I will write B, and number of words for B, again I need to write in this way. So number of words for B. Done. So this will do for what? Number of A. Now I want to observe what it will contain. So I can print this particular thing. So I can print this. Initially it is the 0. Okay, when it will be done, it will be incremented. Okay, so this is what? Number of words B and number of words equal to A. So this we have done. Now next part is what? Now we have to convert what? Compute the term frequency for every document. We have to convert the term frequency for every particular document. Now, if you can observe for every particular word, that is number of words of A. So this will be giving like number of words of A, and this will giving the number of words of B. So in this way, we have what frequency of every particular Mars is present one, the is present two times, so it will be two. So this we have displayed what TF. Now I want to print what IDF. For IDF, first I need to first I need to create one particular function, that is sorry, this is only this I have converted only the term frequency. Now term frequency, if I want to compute, so I want to define one function, that is the EF. Now this is my user defined function, compute TF. I want to find out term frequency. So I'm passing two things. One is what, in which my dictionary, what dictionary where I have stored, and then is what bag of words. Bag of words I have for A document also, and the for bag of words for the B document also. So I have written bag of words. Now in this particular function, what I need is I'm going to define one dictionary, that is term frequency of every particular dictionary. Suppose this particular dictionary is TFDICT. This is TFDICT, equal to, this will be null. Initially it will be what, null. So I have done null. Then bag of words. So bag of words of count, every particular count I need. So I'm going to write down bag of words of count. So I should write any particular name. I can write bag of words of count. You can type any name, whatever you want, words. Then I need count of it. So count of it equal to length of how many words I have in my bag of words. So it will count how many words I have in the bag of words. Once it will find out the how many word bags, how many words. So for every particular word, for every particular word and count, I need what, count also. In where, in my directory. Where my directory is stored, my directory is work directory. I have the word directory that I'm going to pass as the function parameter. So word directory dot every particular items. For every particular items, I need this. So then I'm going to write down. Next one is what, TF, means if I want to find out the term frequency of every dictionary of word, so I should write down TF word, and then I will write down count. It is what, count. Count of occurrence divided by total number of this. So total is converted into what, I'm going to convert into the float, and this total number of this will be passed here. Okay, bag of count. And then I'm going to return my TF. I'm going to return my frequency, that is TFDICT. Okay, so this is my function. Let me check for the any errors I have. This is function. So for this function I need is colon. Done. So now I'm going to call this function. How should I call? If I want to find term frequency for document A, so I will pass compute, and then I have what, compute TF. My function name is compute TF. What I should pass? I should pass two things. First one is what, number of words A, number of words in A, my dictionary of A, and then bag of words. My bag of words is in what, bag of words of A. So number of words and bag of words of A. So this will find the frequency of A. I should write TI. It is T. It is capital T. And I've written the small t. So it is conflicting. Done. Now, if I want to do same for what, term frequency B. So I'm going to write down B, computer TF. Now words with the B, and what number of words and bag of words for the B. So TFA and TFB. Now, if I'm going to print this particular things, I have TFA. So TFA. Jupyter 0.2. Now you can compare this with our particular table. 1.2 is 1.5 is nothing but 0.2. 1.8. So if I'm going to now the print for B, so I have T, F, and B. So 1 divided by 8. For ease, I have the 1 divided by 8. So you can observe ease is 0.125. So this is how we are going to convert term frequency. Now I need to display what? Inverse frequency. So for inverse frequency, again, I want to define one particular function, that is compute, my user defined function, compute IDF. Okay. And this is what? Of documents. This is of documents. So I have written documents. Done. Now, next is what? I need maths. I need library maths because I want to count the time. Now, n equal to what? N equal to length of documents. I need to find out the length of documents. So I have written documents. How many documents I have? So I have written length of documents. Then next, after length of documents, what I need to do is I need again dictionary for my IDF. So IDF dictionary equal to. So what I need to store? dict dot from how many documents I have. So from keys I need to pass documents. How many documents I have? So if I will start with the 0, documents of 0 dot keys comma 0, create a new dictionary for the iteratable item. So I have created a dictionary for this. Okay, so my dictionary is created. Now next is what I need to find out for particular document. So for document in documents, so documents I'm going to pass is the parameter of function. So from document in documents, I should search for word. I should search for the word and bell. Okay. In document items, where I want to search is document dot items. So I want to search in document dot items. Now next is what? If your value is greater than 0, if value is greater than 0, means that particular word is present in that particular document. Word is present in the document. So we are going to increment our IDF by 1, because IDF is what? Out of total number of documents, in how many documents your word is present. So we are going to increment what? IDF, and then I have the directory IDF dict, and then for every particular word I'm going to increment by 1. Done. So this is be done. Now this we have to repeat for every particular. This we have to do for what? This is only like IDF we have incremented. Now we need what? We have to divide this particular word with the total number of documents. So for that purpose, we have to do what? So for that purpose, we need to define again one for loop. So here we are going to write down for loop. In this particular for loop, word and value in which item? Just I have created what? IDF dict I have created. So but for every particular items, I need to check that IDF dict equal to of any particular word, IDF dict of any particular word equal to match what I need? Log. I need what? Log n. So I need to call the function log of what? N. N is what? Number of documents. Divide by the value in which how many documents your this particular value is present, a particular word is present. So this we have done, and then we are going to return what? We are going to return the IDF dictionary of particular word. So this we are going to return. or if we can return the complete dictionary also. So we have returned. Okay. So now I'm going to run it to check the errors, and then we are going to see. Okay. If this is if after if I need what? I need one column. That now if I'm going to write the code. So my IDF equal to I need to compute IDF. So I will write compute IDF in the bracket. What should I write? I should write the number of words in A and number of words in B. So that I want to document. So two documents I can return in square bracket. One is what? One I have with the number of words in A, comma, number of words in B. Both corpus we can find out. Now this will number of words. It is number of words. Okay. Now we can print what? IDFs. See, these are the IDF. You can observe. Uh, Jupiter 0.69, largest 0.69. So if you can observe, we have the IDF. IDF is what? Jupiter is 69, largest is 69. And in any particular, if on towards Sun, in IDF 2, so it is 0.086. So you can observe here, we have the Sun, that is 0.08. Clear? In this way, we can find out what? Our IDF. So now if you were to observe fourth is 0.69. So you can observe over here, we have what? Fourth is again 0.69. In this way, we have calculated IDF. Now the turn comes for the TFIDF. TFIDF is nothing but the multiplication of your value and IDF. Value means what? Your frequency, and IDF are stored in IDF of words. So again, we are going to define one function to calculate compute for computing the TF-IDF. So I'm going to write down compute TF-IDF. What I'm going to pass in the TF-IDF, it is function, so space is not allowed. So for TF-IDF, I need to find out one is what? Bag of words. So TF bag of words I need to pass. And then I need to pass what? My IDFs. Which are the IDFs I have stored in my function, in my variable, sorry. So IDFs I have returned. Again, I'm going to make one particular TF IDF that should be blank. And then I'm going to write down what? For every particular word. So for word, every particular word and value in what? My TF bag of words, where we are passing TF bag of words. So TF bag of words. Now in TF bag of words, I'm going to copy it. TF bag of words, comma, IDFs. So in IDFs, I have TF bag of words and IDFs for value TF bag of words dot items. I should write dot items. Every particular item I'm going to check. So for every particular item, I need to check now TFIDF. So TFIDF of word equal to value into IDFs of word. Value into IDF of word. And then I'm going to return what? I'm going to return TFIDF. Okay. So this I'm going to run what? TFIDF. Now I'm going to call, first I'm going to run this and then I'm going to call this. I need colon over here. So now I'm writing the code. So TFIDF A. First I need what? TFIDF A. So TFIDF A equal to, I need to compute. What I need to compute? TFIDF. So I will call the function TFIDF. In that I need to pass what? My term frequency of A and my IDFs of A. IDF of A. My IDFs of A, I have stored IDFs of A, IDFs. So I have stored in the IDFs. This I'm going to pass. Okay. Same I will do for what? My document number B. Done. So now if I want to print, so I can print it. See, Jupiter is 0.13, 0. Planet is 0.13. So here you can observe that we have 0.13, planet we have 0.13, largest we have 13. Rest all will be 0 for first document. And so we can observe only 0.13, 0.13, 0.1. Rest all will be 0, means no importance of that particular words. These are the important words. Jupiter, planet, largest, that are the important words. Now, if I'm going to find out TF-IDF B as per document B. So as per document B, if I'm going to run out, so you have the, now see, you have the sun equal to 0.086, from equal to 0.086, planet will be 0.086. So you have this, that everything will be 0.086. And now if I want to present it into the data frame, if I want to present it into the terms of data frame, so what I can do is df equal to pd dot, we have already imported pandas, so pd dot data frame. So in this data frame we are going to pass our two things. First one is what? In square bracket we are going to pass two things, that is TF-IDF A and TF-IDF B. Both we are going to pass in this particular data frame. So it will converted your data frame, and that we can see into the tabular format. Done. So this completes your seventh assignment, second part, that is representation of document by calculating term frequency and IDF frequency. I hope this video will be useful for you. Thank you.